Okay, this is the last video of lesson 2 in our acid-base series, and we're going to concentrate on the details of the anion gap. Now, this has been covered, certainly in the renal section, we just covered it, but I want to sort of cover it in the context of the acid-base problems that we've been talking about, with a little bit more detail added, just to reinforce it, okay? Because it's something you have to know. So, the anion gap, the first thing, let's start with the fact that anions, the concentration of anions and the concentration of cations in the body have to be the same, okay? Yes, there are very small imbalances that produce voltage across the membrane, but you guys will remember that those imbalances are really, really small. Chemically, you can't measure those. So for all practical purposes, the anions and the cations have to be at the same concentration. They have to concentrate each other out so that you have electron neutrality in your body, okay? Now, usually when we measure cations and anions, we're only measuring the major ones, the ones that have a high concentration. So the major cation is sodium, and that is and the major anions are chloride and bicarbonate, okay? And when you add these up, you get 124. This is 140. So there is an apparent gap between your cations and your anions, but note that that is an apparent gap. It's not a real gap, okay? And the reason is because you're not measuring all the anions and you're not measuring all the cations. If you did that, the two numbers would be equal, but they're not. These are just the commonly measured ones, okay? So we have an anion gap of the difference between the 140 and the 124, okay? All right. So this is just an apparent gap. It's not a real gap, all right? That's the first thing we have to get across, all right? Now, the anion gap shows the concentration, shows changes in the concentration of the unmeasured ions, okay? So that is relevant to acid-base. Let's say we have a metabolic acidosis. So we're adding a non-carbonic acid to our system, okay? When that happens, our non-carbonic acid dissociates into the hydrogen ions and our non-carbonic anion, okay? So what we're doing when we do that is we're adding a non-carbonic anion to the system. And assuming it's not measured, which most of them are not, okay? If it's lactic acid, this is lactate, it's not measured, then you're adding this anion to the system, but it's an unmeasured anion, so it's not going to come up in your critical measurements, okay? You're also adding hydrogen ion. The hydrogen ion combines with bicarbonate and shifts our carbonic acid equation to the left. Our bicarb is disappearing, so you're adding this, and this is going away, okay? So, this is an unmeasured anion, okay? Generally speaking, that's true. Unless it's chloride, then it's basically going to be an anion that you're not measuring, okay? So this could be lactate, we've increased it, okay? At the same time, we have taken an anion that we are measuring, bicarb, and we've decreased it, okay? So what that means is that our anion gap is going to get bigger because our anion gap was the sodium minus the sum of the chloride and the bicarb. Well, my bicarb went down, it disappeared. So the apparent gap between those anions and sodium, our major cation, got bigger. Now notice that electron neutrality is still maintained because we did add our non-carbonic anion to the system. But this isn't measured. So the anion gap is a gap between the measured anions and our measured cations, sodium. And it got bigger when we added acid. So when you see a bigger anion gap, that's an indication that you have an acidosis on your hands, okay? That could be caused by an increase in hydrogen sulfate, which accumulates in renal failure, okay? It could be due to an increase in lactic acid, which accumulates in hypoxemia. It could be due to ketones, which accumulate in diabetes and in starvation, okay? These are the typical kinds of things that will increase the anion gap, okay? And it could also be acid metabolites of some poisons like methanol and ethylene glycol, okay? And these can increase the anion gap as well. They're indications that you have an acidosis on your hand due to something, metabolic acidosis, okay? Okay. There are some metabolic acidoses that do not increase the anion gap, and the one that should make sense to you is hydrochloric acid. So if my non-carbonic anion is chloride, because I've added hydrochloric acid to the system, chloride is a measured anion. So yes, chloride will go up and bicarb will go down, but the sum of chloride plus bicarb won't change and my anion gap won't change, okay? So what that means is that an increased anion gap may indicate that you have a metabolic acidosis, might, but it isn't definitive, okay? It doesn't have to, all right? And this is a great example of where it wouldn't, when you're adding chloride, which is a measured anion, okay? Instead of something that's not measured like lactate, okay? All right, that's all I've got. Thank you for your attention, and I'll see you guys in the rooms.